Welcome back. Let's take a look at lesson 2, the auto deploy overview. So we'll take a look at the purpose of auto deploy and describe how auto deployed ESXi hosts boots. So what is this? Auto deploy is a way to centrally deploy ESXi images all from vCenter. Now you already may be familiar with, okay, I can install ESX servers from an ISO, right? You can actually just use an actual CD device, or maybe have an ISO mapping mechanism through your lights out connection to set up your servers that way. Of course, you can do it over a USB stick too. But if we needed to deploy multiple ESX servers rapidly, we can also do this from a central point of the vCenter server. Remember, the ESXi image itself isn't very big. It's just under 300 megabytes. And in fact, another element about ESXi is that it actually, when a host boots, no matter whether if a host boots off of its own local boot drive, or if it boots from a SAN, or if it even just boots off of the network, the entire ESXi server runs in memory. So it's an in-memory operating system, making conducive to having this being booted in a stateless fashion. Imagine if your ESX servers don't have local boot drives, this makes a single image that all of your ESX servers could be booting from, which means that updating the image, all that is required is updating the one image on auto deploy. And then when the servers reboot, they're stateless, they'll reboot with the new update to the image. So that makes patching a far simpler process for especially large scale environments. Now you can actually have, if you like, maybe you have slightly different hardware versions across different clusters. So you could have one image in auto deploy for one cluster, a slightly altered image using Image Builder for an image that's in a different cluster because it might have slightly different hardware attributes. So you can have different images, but in the case of maybe you have 3 clusters, then you need 3 images. Each cluster may be filled with 30 servers. So that would be 90 servers, but being sourced from a central point of just 3 images. But with the host being stateless, right, all we have to do is just download that 300 megabyte image from the network, right? This can be done locally. This can even be done over wide area networks, right? It doesn't have to be a local network only solution. It can be applied over much longer distances. The thing is, though, the host state and configuration, since they run entirely in memory anyway, why not make this the standard in a stateless type of fashion? The only thing when the host is shut down, all that state information is, of course, cleared from memory. So that means we have to have these servers PXE booted. They will, by default, do that as they go through their boot process, right? They'll probably try to boot off of their hard drive first, or then their CD device, and then the network is the third option. So you can set up that order, but it's going to essentially get to that if there is no local drive, if there is nothing in the CD, DVD drive as well. And it basically is dependent on having an image being built by Image Builder. vCenter can then store that in its auto deploy repository. You also use host profiles to configure those hosts after they've been imaged with the image from Image Builder. So basically, auto deploy is a combination of providing the images that were built through Image Builder and the configurations of your ESX servers through host profiles. So the benefits, lots of hosts can be deployed rapidly and concurrently, and a standard image can be shared across many hosts. Your host image is essentially been decoupled from the physical server, simplifying host recovery. Imagine that too. If a host fails, you have a complete hardware failure, all you really need to do is simply do a hardware swap out, grab the MAC address of that new hardware, and then update your auto deploy so that auto deploy knows each MAC address and knows what network information to send that. We update that information in what we call our auto deployment rules. And then when the machine boots up, it'll get the image that was previously being used by the machine that it actually had replaced. So like we said, auto deploy can run in a couple different modes. It can run in what's called stateless mode. It can be run in stateless caching mode. It can be used as a stateful install. Basically, the true sort of, basis of auto deploy is completely stateless. The ESX servers have no local storage. They always just simply boot off of the network, get whatever image has been stored on auto deploy. Stateless caching, on the other hand, the servers still boot in a stateless fashion, but if there was a local hard drive, why not just cache the image there in case that if the server were to have to reboot, if vCenter wasn't available while the server's booting, at least the server can boot off of the previous copy of whatever image it booted from last. So it has the cached as a backup. I like that one a lot because then it doesn't have a huge dependency on vCenter's uptime like stateless caching does. And then stateful install, well, that's like a typical network-based installation, right? A Kickstart, for instance. The ESXi image is actually installed on a local boot image, and now that server will then boot off of that image going forward. It will never go back and use auto deploy. So it's basically using auto deploy once, where the other two methods, the host will always use auto deploy as its first choice. So in stateless mode, every stateless host boot is like a first boot, right? It's storing everything in memory and never anything on disk. A host configuration is pulled from a host profile. So the host profile contains all of the configuration settings for that host. This makes easy removal and replacement of failed hardware. Like we mentioned, hardware replacement is actually pretty straightforward here. You have a easy use in scaling an environment. If you need to add more hosts, they can all be pulled from the same image. You don't need to add any more images. You just add more hosts and then update autodeploy with basically the MAC addresses of those hosts so that autodeploy knows, oh, we're going to install software on those systems too. So this minimizes the dependency on autodeploy. Well, the stateless caching, I should say, the stateless caching element will then help minimize the dependency on the autodeploy service, right? Because like I said, stateless caching will also provide a local hard drive as a backup. So in stateless caching, if you enable this, then we simply have the servers boot and still run entirely in memory. And every time the ESX server reboots, it's always going to attempt to get whatever the current image is from the autodeploy server. But because the host had a local hard drive, when the host has booted, it will store the image as a cache on that hard drive. So that if vCenter is, for whatever reason, offline, when this ESX server boots up, at least he has a backup of that image. So basically, it is configured to overwrite and preserve existing VMFS, or it can be configured to overwrite or preserve existing VMFS data stores. You probably want it to be configured to preserve if it's an environment having been booted potentially multiple times. The stateful install is different from the other two, though. This is where we use auto deploy just once. The server boots for the first time. It gets its image downloaded off of the auto deploy server, but it actually will be statefully installed on some local boot drive. So now, as far as updates go, we'll actually update these servers in the traditional method. We'll use this, vSphere Lifecycle Manager, the essential replacement for, the VMware Update Manager, and patch the system using that system. Very different than the stateless models. The stateless models, basically what you do there is you update the image on auto deploy. When the server reboots, it gets the new image. Stateful installs, you'll just use a stateful patching management system using the vSphere Lifecycle Manager to patch your host. Now, since the host traditionally will not have a local storage to store the configuration settings, it's all in memory, right? Well, there may be things that we want to make sure are stateful elements, right? So things that just to be aware of, the locations of the configuration, the state information, where has this all been replaced, right? Because what normally would have been on the ESX server boot drive is now going to be needed to be stored somewhere else. So like we just mentioned, the image state, which contains the ESXi base image, the drivers, that's an image profile that we used Image Builder to create. The configuration, like networking settings, storage, NTP settings, and all that, that's coming from a host profile. The running state, where the ESX server sits in the vSphere inventory, that's stored all in vCenter. And then the event recording, log files, core dump, where an ESX server typically would have its own local log files. The ESX server usually has its own local core dump partition. Well, those aren't going to be able to be something that the ESX server can do any longer. So there are actually services that will be enabled on your vCenter server. So auto deploy doesn't just enable one service, the auto deploy service. There's actually what's called a core dump collection service. And you can also set up a logging service. Now, usually these days, you can just have an ESX server send its log to some other central logging server, like using Log Insight. And then finally, what's not noted here is that if your ESX server is supposed to be part of an AD domain, you can set up an authentication proxy service on the vCenter server that will authenticate your ESX server to the domain so that the host can continue to do that, since it's stateless under most situations and it won't have preserved any of the credentials. So that's a quick look at the overview of auto deploy. We'll take a quick break. In our next section, we'll start taking a look at more details in other configuration options. So we'll see you in a few minutes.